Example 8. In example 8, we're going to look at functions and determine their end behavior models when the right behavior model is not necessarily the same as the left end behavior model. So it's very important to note that a function's right and left end behavior models are not always the same function. And in this next example, we're going to see that. So we're going to let f of x equal x plus e to the negative x, and we're going to show that g of x equals x is a right end behavior model, and that h of x equals e to the negative x is a left end behavior model. So before we do this, we're going to take a second, we're going to look at the graphs. So this is the graph of x plus e to the negative x. And as you can see, it doesn't really look like anything we're too familiar with. And now what I'm going to do is I'm going to zoom in a bit, and I'm going to graph e to the negative x. So just looking at these two graphs, you see that they don't look very similar. However, as I zoom out, we see that the left end behavior model, which is here, starts to look very similar. And if I were to graph y equals x, you see how the right end behavior model can be graphed by this more simple function. So again, the right end behavior model is as we move towards infinity in the right direction, and you see how y equals x represents the right end behavior model, and y equals e to the negative x represents the left end behavior model because the graphs mimic each other. So again, if I zoom in to the middle, you see that around 0, these graphs look nothing alike. However, as I zoom out, you see the right end behavior model is y equals x, and the left end behavior model is e to the negative x. So then the question is, how do we actually show this? Well, to show a right end behavior model, we're going to let the limit as x approaches infinity of f of x divided by g of x. And this is where we want, after we take the limit, for it to equal 1. So we get that this is equal to the limit as x approaches infinity of f of x, which is x plus e to the negative x, divided by g of x, which was just x. And now we're going to take our limit, but first we're going to do some algebra. So this is the limit as x approaches infinity of x divided by x plus e to the negative x divided by x. So this is the limit as x approaches infinity of 1 plus the limit as x approaches infinity of 1 over x e to the x. Now it becomes 1 over x to e to the x because of the negative exponent right here. So now we get this as 1 plus, and as you approach infinity, this denominator is going to get very, very large, so then the whole fraction just goes to 0. So you get 1 plus 0, which is 1. So because we got 1, we then know that this is a right end behavior model because we'd let the limit go to infinity. Now we want to check the left hand behavior model. So we're going to take the limit as x approaches negative infinity of f of x divided by our end behavior model for the left. And so that was h of x. So this is going to be x plus e to the negative x divided by, and our h of x was e to the negative x. So now this is equal to the limit as x approaches negative infinity of x divided by e to the negative x plus the limit as x approaches negative infinity of 1. And so from here we're going to get, this is the limit as x approaches negative infinity of x times e to the x plus 1. And then as you're going to let this go to negative infinity, this piece right here is going to approach 0. And let me show you why that happens. This is the graph of x times e to the x. And so as you can see, as we move down, we get, as we go towards negative infinity, this has a horizontal asymptote at 0. The algebra reason for this is when you plug in negative infinity, you're going to get negative infinity divided by e to the infinity, because the negative exponent makes it go to the denominator. So this is a good graph to know, and know that as you approach negative infinity, you get 0. At this point, you can also check it on your graphing calculator. So then this becomes 0 plus 1, which is just 1. So now we've shown it's a left-hand behavior model. All right? On your own, I want you to try to determine the right and left end behavior models and prove that they are end behavior models. A quick trick, you usually pick between these two. So typically the positive one will be the right end behavior model, and the negative one will be the left end behavior model. So go ahead on your own and try that right now. All right, let's give it a go. So for the right end behavior model and the left end behavior model, the very first thing I want to do is go ahead and graph these to see what they actually look like. So this is the graph of e to the x minus 3x. And as we can see, we really don't know what this thing looks like. It looks like it goes to infinity in either direction. But let's take a look. So I'm going to put two graphs on the screen. And again, they don't look like they match up very well. But as I zoom out, you can see right away that the negative 3x, which is the gray line, looks like it matches with the left end behavior model. And the e to the x, which is the green one, looks like it matches up with the right end behavior model. So as I zoom out more and more, you can see how, whether I have the actual graph there or not, you can use the two more simple graphs to represent the end behavior models. So now what we're going to do is we're going to actually work them out. So I'm going to say my right end behavior model. I'm going to represent it by g of x is equal to e to the x. And now we're going to go ahead and do some limits and solving. So since we got that as the limit as x approaches infinity equals 1 when you divide f of x by g of x, then g of x is equal to e to the x is a right end behavior model. Now let's go ahead and try the left end behavior model, where I'm going to let h of x equal negative 3x. And then we're going to go ahead and take the limit as x approaches negative infinity of f of x divided by h of x. So here we go. Now this part's tricky. What I'm going to do is substitute in negative infinity with just infinity. And the way I'm going to do this is by letting the limit as x approaches infinity. And the way I get rid of the negative is by placing it in for x. So this becomes e to the negative x and negative 3 to the negative x. And so now that we've gotten 1, we know that h of x, which is equal to negative 3x, is a left end behavior model.